corollary of Stokes' theorem. That is, if phi is continuously differentiable scalar point function and S is a surface bounded by a curve C, then the line integral of phi dr vector is equal to the surface integral of cross product of n vector with del phi. That is the gradient of phi ds. This we need to prove. So to prove this, I need to take a constant vector A and taking its dot product with this left hand side. And then I'm going to apply the Stokes theorem in this. So let A vector be the constant vector, any constant vector, then by Stokes theorem we have this left hand side, that is the line integral over C phi dr vector, taking the dot product of this constant vector with this, and is equal to, because it is a constant vector, I can take this inside the integration. So it is A vector phi. Phi is a scalar function. So taking the product of this and then having our dot product with dr vector. So now I'm going to apply the Stokes theorem for this function. That is equal to the surface integral of curl of this function, that is A vector phi, and its dot product with n vector ds. Is it okay? Fine? Yes? Okay. Let's get the value of this first and marking this as 1. Now curl of A vector phi. This is equal to, yes, it is the summation I vector cross product with curl of A vector phi with respect to x. Right? So this is further equal to summation I vector cross product with, okay. Derivating this, writing the first function, taking the derivative of second one, plus second function taking the derivative of the first one. So this is equal to summation I vector cross product with A vector partial derivative of phi with respect to x plus summation I vector cross product with phi partial derivative of A vector with respect to x. Because this is your scalar function, I can write this with I vector and taking cross product with A vector, taking this in bracket, plus again this is your scalar function, I can take this outside of the summation. So this is phi summation I vector cross product with partial derivative of A vector with respect to x. And this is nothing but the grad of phi, the gradient of phi, and its cross product with A vector plus phi, and this is, just take this in bracket, this is your curl of A vector. And because A vector is a constant vector, so curl of A vector is 0. So I'm having this value to be grad phi cross product with A vector. Reason, curl of A vector is equal to 0. Please mark this as 2 and let's substitute this value in 1. That is over here. So substituting 2 in 1, we get, so putting the value of this, that is grad phi cross product with A vector. This is grad phi cross product with A vector and dot product with n vector ds. So this is equal to, if I interchange these two, I get the negative sign. So it is negative of surface integral of A vector cross product with del phi and having its dot product with n vector. In the next step, shifting this cross to this and this dot to this. This is the result that I'm going to use. So this is surface integral of A vector dot product with grad phi cross product n vector ds, and taking this in bracket. And because this is your constant vector, I can take this outside of this integration. So this is equal to negative of a vector dot product with this surface integral grad phi cross product and vector ds. This is the result. What is on the left hand side? It is a vector dot product with line integral over c phi dr vector, and on the right hand side I'm having minus of a vector dot product with the surface integral. Taking this to the left hand side, we get the sum of these two terms. Equal to 0. Right? And now taking this a vector common from these terms, so a vector dot product with the sum of these two integrals equal to 0. Right? And because a vector is any constant vector, so a vector is arbitrary. But a vector was arbitrary and because a vector is arbitrary, so the sum of the integrals in the bracket is equal to 0. Yes? The sum of these two integrals is equal to 0. Or we can write further as the line integral over c phi dr vector is equal to, taking this to the other side, this is negative of the surface integral. Managing this negative sign, we can write the surface integral to be as n vector cross product with del phi ds. So this is what is needed to be proved. So hence the result. Okay, thank you.